Welcome, everyone. On behalf of Saskatchewan Organics, Deb Tuchelt, and myself, Joanne Ralph Eckstein from the Saskatchewan Forage Seed Development Commission, thanks for joining us today. We've got a story to share with you about Canadian innovation in plant breeding, beefs and bouquets, of doing demonstrations in commercial seed production fields in Northeast Saskatchewan, the results, what we learned, and we'll conclude with ideas on further questions that we can take a deeper dive into on behalf of seed producers and livestock producers in the province. We're going to begin our presentation today with Dr. Doug Catani. Doug is the breeder of the genetics that we have used for this project, and he's the best well-positioned to explain the genetics and the origin and the why and the benefits of why we chose this type of intermediate wheatgrass.
Okay, what is Kernza? Kernza is intermediate wheatgrass that is produced organically. Intermediate wheatgrass has historically been used as a forage grass in Western Canada. And in the 1980s, the Rodale Institute in the US began looking into perennials to see if they could find one that could be used as a grain to help feed the human population. The one they came out with that had the greatest potential was intermediate wheatgrass. In the early 2000s, the Land Institute of Salina, Kansas took over the materials that the Rodale Institute had developed and began a breeding program in earnest to produce a perennial grain. This is intermediate wheatgrass that has been dehulled, much like oats or barley. It has to go through a dehulling process in order for the grain to be freed from the lemon, the palea. We are breeding to try to get plants that will do this naturally, but until then, we will be dehulling it. The inset that should be showing up is of actual seeds, and you can see that they have different shapes and sizes, and a lot of this is due to the type of spikelets they have, where they can have up to 12 florets in an individual spikelet. This gives us the various shapes and sizes of seeds. Breeding to remove this is something that is also being looked at in the future. So why is there a lot of interest at this point in time? Well, 2 or 3 years ago, General Mills came out with this statement. In their aim to reduce greenhouse gas emissions, they thought they would utilize Kernza in their food processing business, and they would like approximately 18 million pounds of Kernza by 2025. Right now, we're probably producing less than 1 million pounds a year worldwide, so there's a ways to go, but this is what spurred on the current interest in Kernza itself. What are some of the benefits we get from having a perennial in our cropping systems? One, we get entire season photosynthesis. Intermediate wheatgrass can undergo photosynthesis at 1.5 degrees Celsius, so pretty cool, 35 degrees Fahrenheit, and it's at 17% its total efficiency. So even at those cool temperatures, we're taking carbon dioxide from the air and putting it into starches and sugars within the plants. Benefits to soil health and structure, and this includes carbon sequestering deeper in the soil. Studies are now showing that the perennial root systems are putting roots deeper in the soil, and as many roots below 1/2 meter in the soil than an annual plant's root system produces in all of its colonization of the soil. So the perennial systems are putting carbon deeper into the soil. Once established, you get excellent erosion control. You can see here that that soil underneath this stand is not going to move. The only place there is potential is where it's been tilled at the edge, but underneath the crop itself, excellent ground cover and excellent soil stabilization. Seed once, harvest numerous years. The idea is to be able to seed it and then harvest for probably 4 to 5 years of grain production. This helps reduce the risk of unseeded acres in the spring. Depending on what our springs are like, sometimes we end up not being able to get all of our acres seeded. It is also a potential dual use crop, and we'll talk a little bit more more about this as we go through. So you would harvest your perennial grain at your normal early August harvest time, and then you could, in the case of this one, this image is taken in late October, you could easily let your animals out on this to graze it and utilize this fairly high quality forage. We did a forage quality on this in December, 2 months after this image was taken, and it still had a relative feed value about 125 and was at 11% protein. Provides wildlife habitat. Hopefully you can see that little bird peeking at us through on the left-hand side and the eggs on the right-hand side in this image. So wildlife habitat, because you don't disturb it until harvest in August, it provides a fairly good habitat for the wildlife in the area.
Thank you, Dr. Catani, for providing that excellent explanation of where we got to today. So after hearing Dr. Catani's presentation on Sask Organics, we decided together with Sask Organics and myself for the Sask Forage Seed Commission to put an application in to actually test drive some of his genetics in the fields in northeast Saskatchewan, where traditionally, since 1950s, we have producers who have high levels of innovation and technology that they put at use to their fields for successful seed production. So we applied in June 2021, and we were accepted for 2 grants, 2021-0960, and that was the research part, or the actual demonstration of the objectives that are listed. So we wanted to look at the production system for seed using this genetics under both conventional and organic systems in commercial fields by seed growers who are already used intermediate wheatgrass in their crop rotations. Then the idea was to evaluate or demonstrate the dual use potential of this crop. So the idea is that intermediate wheatgrass is harvested in end of July, beginning of August, but it has a very rapid growth habit and ideally suited for rotational grazing. And if you don't have rotational grazing, then some of the value of the straw that is dropped after the combining, the bales can be used as fodder for the steers that you're feeding over the winter. So keep in mind that in the first year, it's just the establishment year. Your seed production year is actually in the second year. So we had enough seed for planting 2 2-acre sites, 1 conventional, 1 organic, in 2021. And the idea was to take half of that, mow 1 acre and fall graze the other, and then seed harvest the second year. We would then look at available nutrients post-harvest of the crops, look at the plant performance, and measure the seed yield and seed quality, specifically the germination and seed size, and look at the feed quality from the chemistry and the digestibility. So that's where we had planned. Doesn't always go as planned. So in our first year of seed production, we seeded at St. Brew, Saskatchewan. We had very good conditions for germinating there. However, it also became a very favored food source for the wild boar population, and we lost a big chunk of the seeded area. We had enough to survive through the next year's seed production, but it was definitely low in quantity. So we reseeded it, and we planted in June 2022 on a site beside it. Again, we had good establishment, and we had first and second year seed production. Although that year, then, it became a favored choice in the fall and into the winter for the extensive grazing by elk and deer. So definitely a source of wildlife. And in the upper right, you can see the relation to the height of this first year seed crop in comparison to the 6-foot tall flag that we had up in the field. Now, on the organic side, we weren't quite as lucky with the establishment. We had several sites planted in 2021. First was in Prince Albert, and it was dry, and there was heavy weed pressure, specifically wild oats. There were very few plants in the entire 2.5-acre piece of intermediate wheatgrass, so we terminated that site. We planted at Kamsack, which is a different climate, very experienced grower on Legend Organic Farms, and we had very good establishment. The odd Canada thistle, some volunteer alfalfa, bird's foot trefoil, and crimson clover, because they were part of the rotation, and they're also a good nitrogen provider. So that was just fine. Unfortunately, the land was sold, and we had to terminate the site. Our third attempt was at Gronlid Sask, and that's the image on the left. Now consider that it was planted by a very experienced intermediate wheatgrass seed grower, and he also had red clover in his rotation. Well, from the picture you can easily see that red clover was definitely more vigorous, and it outcompeted the intermediate wheatgrass lickety-split. So we had to terminate that site. But we would not give up because we knew it was just a matter of finding the right recipe. So in 2022, we found a new site at Carrot River, and we had perfect timing for rain. Now I'll explain to you the results that we had. Starting with the first year perennial grain organic production system, which we can call Kernza. That is intermediate wheatgrass grown under organic production. That's a registered trademark of the Land Institute. So on your left is the crop in the upper left, and that is approximately June. So you're already seeing good height. And by August 3rd, we had perfect maturity for swathing. As you can see, it was a very nice stand. And by the 14th, we were ready to combine it. Immediately behind the combine, as you can see with the red tractor and the old square baler that borrowed from the neighbors, we did the bales right after combining. And the next morning, the transportation was brought to, the truck was brought to the farm, and the trucker's son and himself and the cooperator, Evan Lefebvre, and his son and myself helped load the bales. Then we took them to the University of Saskatchewan, where the graduate students in the upper right and Dr. Greg Penner and Gabriel Ribeiro's lab met us, and boy, they really knew how to unload those bales and stack them perfectly. That stack remains today, and we're waiting for additional funding to test the 2 years of organic production. And the results that I'm going to present on digestibility were 2 years of seed production under conventional system and the bales that were taken off that field. So from the conventional site of 1.5 acres, about 375 pounds of seed, 12,000 pounds of baled feed, and those bales were used at U of S by the undergraduate students for their classwork in fall 2023, because they also had the 2023 production year. So second year seed production, conventional, from St. Brew, and the students use that baled feed. The seed is going to be cleaned later on this winter and used for planting at a biosphere area in Redberry. Now, going to the organic site. In 2023, 5 acres were seeded onto fallow. Incredibly good conditions. Very good soil up there, and the grower knew exactly what he was doing. So that first year was 800 pounds per acre, and it was actually very clean seed lot. 200 or some bales were delivered to U of S for the feeding studies, and again in 2024, as the picture I just showed you. Now I'll turn to Dr. Greg Penner to explain the results of the feeding study done by the undergraduate students. Thank you for joining us, Dr. Penner.
Hello, my name is Greg Penner. I work in the Department of Animal and Poultry Science at the University of Saskatchewan in the College of Agriculture and Bioresources. I had the opportunity to collaborate on a project titled Demonstrating the Dual-Use Potential of Simultaneous Grain and Forage Production of Intermediate Wheatgrass when grown in Northeast Saskatchewan under organic and conventional cropping systems in collaboration with the Saskatchewan Forage Seed Development Commission. In this project, our collaborators here at the University of Saskatchewan were Gabriel Ribeiro and Catherine Seidel, and a group of third-year undergraduate students, which evaluated the digestibility of conventional intermediate wheatgrass grown in 2022 and 2023. Students in this study used beef steers to evaluate voluntary intake and nutrient digestibility using diets that contain nearly 56% straw. So these diets were very high straw-based diets with the purpose to evaluate the digestibility of the different straw types. The straw types used consisted of intermediate wheatgrass straw that was produced in 2022 or 2023, and we compared that to wheat straw. The students in this study managed the heifers, including general care and feeding. They measured the amount of feed provided, and the amount of feed that was refused by the steers on a daily basis. Students also collected fecal samples once the steers had adjusted to the diets to evaluate diet digestibility. What we found was that the chemical composition of the intermediate wheatgrass straw was similar to that of wheat straw. The crude protein concentration in the current study was around 10%, and the NDF concentration was in the high 50% range. Feed intake was numerically less for steers fed the intermediate wheatgrass produced in 2022 than 2023, and this reduction in intake likely reflected the slightly greater ADF and lignin concentration in the intermediate wheatgrass that was produced in 2022. We also observed that digestibility of dry matter and of crude protein were less for intermediate wheatgrass that was grown in 2022 than 2023, and this probably further helps to explain the reduction in feed intake that we observed for the straw from 2022. In addition, we saw numerical reductions for organic matter, acid detergent fiber, and gross energy from straw grown in 2022 than 2023. However, when we compare the intermediate wheatgrass straw to wheat straw, we actually didn't see any differences between the two straw sources. What this tells us is that intermediate wheatgrass straw could be a useful feed resource for beef cattle producers, and feeding intermediate wheatgrass straw is expected to result in similar performance outcomes to cattle that would be fed wheat straw. That said, as is common with many straw sources, we do see yearly variation, implying that we need to know the chemical composition of the straw that we're using. So feed testing is critical. I'd like to thank the Saskatchewan Forage Seed Development Commission for the opportunity to participate in this project. And certainly the students gained significant benefit from learning how to manage cattle under research conditions and in evaluating intermediate wheatgrass straw as a forage source for beef cattle.
As part of the conclusion for this project, Deb at Sask Organics challenged us to think about what we could do next, future questions that we can ask on behalf of conventional and organic seed producers. So I put some thought into this and talked to the other intermediate wheatgrass seed producers. Number one, if you're going to produce seed of intermediate wheatgrass, it has to be profitable. There needs to be market demand. Currently, there's less than 10 seed producers in Saskatchewan that supply most of the Canadian demand, in addition to some seed producers in the Peace region. Beyond that, the market demand would have to include other uses for seed. So one of the things we've looked at would be what value can we get from the seed other than the seed in and of itself. On the top left-hand corner, you'll see a tote, and that seed was harvested from the Kearns, i.e. organic production field in 2023. And it's about approximately 1,500 pounds of seed. And the same was in 2024 production. That seed has been cleaned in Saskatoon. And we're happy to report that that now is going to be used after it's dehulled. It's going to be used for a test mash to see if we can actually make value-added, sustainably produced, prairie-grown Canadian whiskey made in Saskatoon with intermediate wheatgrass seed. That would definitely create market demand. There's no doubt we'll have a lot of regulatory hurdles, but we have to start at some point, and it takes quite a few years from the mash to the whiskey. Number 2, there's a lot of work in agronomy we can do. So if you shift your eyes right, you'll see the commercial intermediate wheatgrass field in northeast Saskatchewan. This is a field that we actually tested plant growth regulators on. On the right, it's plant growth regulator. On the left, that's the day after the windstorm came through in 2023, around July 1st in that area. And it's flat on the ground, and it took a long time for it to come up. We also have to look at fertility in both conventional and organic system. When is the ideal time to apply the NPKs and address the micronutrients and macronutrients? Weed control is a bit of an issue in conventional as well as organic. Night flowering catchfly is a problem weed, and it's also a noxious weed in some areas, Canada thistle. And then in the organic systems, they are restrained by not being able to use synthetic fertilizers. So in the upper right picture, you will see the 2023 stand of the organic crop. It was very interesting that the seed grower also had alfalfa and alsite clover in that field years past. So it was a very interesting smattering, if you will, of legumes in amongst that intermediate wheatgrass field. However, it was nowhere near enough to compensate for the amount of nutrients that were taken out by that 800 pound per acre crop. So the next question we'd have to ask is, what legumes would be the ideal mix to intercrop with the intermediate wheatgrass, Kernza, and how much and when and how? So then we look at feed sources for livestock. And again, there's a lot of work to be done there in terms of what time is best for fall grazing, how much is too much, and how much is done by the wildlife unintentionally. So then we go to the other environmental type of aspect. As we know, there's a lot of interest in regenerative agriculture and sustainable systems. Well, when you look at the crop of intermediate wheatgrass in and of itself, it has continuous ground cover. It has an incredible root system, as you can see on the left. That is from the commercial field. That is one plant that I dug up in 2024. It is a 3rd-year seed production field, and it is probably going to do 5, potentially 6 years of seed production in total. The root system is incredible, and it begs the question of how do we quantify how much carbon is being captured and sequestered by that root system? How deep is that carbon being placed? And also the whole soil microbiome and the water infiltration that planting this crop does to the environment. Next, I'm going to take your eyes over to the far right, because this was very interesting observation. We had a trap up in the field and we did sweep netting. And what we found in the intermediate wheatgrass field, surprise, surprise, are a lot of bees creating their habitats in some of these perennial grain system fields. These are solitary bees that have their homes in the ground. And that is just one bee of 25, 30 that we had within a few days. So it really hit home the value, the ecological value, and the biological diversity that we have with opportunity with these crops. There's also probably homes for beneficial insects that we've got no idea about. That's the kind of research work that would be valuable going forward. The other point that is interesting about intermediate wheatgrass, and Doug Catani and his graduate student now working at Agriculture Canada, Sean Aslin, they're selecting intermediate wheatgrass lines for planting in areas with salt that needs to have salt tolerance in the rotation. And there's a lot of opportunities for this crop. Lastly, the Saskatchewan seed growers, as well as in the Peace region, know how to grow this crop. No new equipment is needed. The knowledge is there, the climate is there, the soil is there. There's a proven track record of adapted genetics, as mentioned by Dr. Catani, all the way back to the 1950s. So now it's up to us in science and technology to put a few more pieces together so that we can keep this crop viable. And then from the livestock point of view, we've got those bales sitting there at U of S, and hopefully someday we can get funding to find the answers to the digestibility in the conventional and the organic system in multiple years. Thank you very much. We do